Hello, this is Group HG7. Our project is the IoT-based blood pressure monitor. The idea started from my own family. My grandmother, like many elderly people, has a deep fear of hospital. His anxiety was the Wyckoff effect. Her blood pressure spiked the moment when he see a doctor. Simply resting in the clinic does not help her internal stress. So to get the truth, my aunt has to measure it at home and manually write every reading on the paper to show the doctor later. We realize this manual process is outdated and inefficient. It's exactly what we want to solve. Our project asks a simple question. How can we build a low-cost, non-intrusive device that measures blood pressure at home but automatically sends that data to the doctor? This eliminates the paperwork and ensure accuracy.
Hi, my name is Bear. So now I will continue with the methodology of this project. And first, the user wears the blood pressure cuff and activates the device at home, allowing measurements to be taken in a relaxed real-world environment. Next, the pressure sensor detects curve pressure change during inflection and deflection. So these signals are sent to the ESP32 controller where the system processes the data and calculates the systolic and diastolic blood pressure value. After processing, the ESP32 transmits the reading wireless to a mobile application using Wi-Fi. The mobile application then stores the data, display the result, and visualize daily trend for easy monitoring. If the reading is outside the normal range, the system prompts the user to recheck, ensuring accuracy. So this continuous operation flow helps user monitoring blood pressure consistently, reduce error caused by clinic-based measurements such as the white coat effects.
Assalamualaikum, my name is Danish Ami, so I will be presenting for our step table. So, firstly, there's social. Malaysia has more people with high blood pressure due to stress, aging, and inactive lifestyle. People prefer checking BP at home to avoid clinic anxiety and the white coat effect. Smartphones make health apps easy to use. Second, technological. IoT, Bluetooth, Wi-Fi, and ESP32 allow remote BP monitoring. Data can be sent wirelessly and viewed through mobile apps. For our third one is economic. Hypertension is expensive to treat. Many devices are costly, so this project offers a cheaper, portable solution and supports local innovation. Our fourth, environmental. Home monitoring reduces clinic visits, fuel use and carbon emissions. Energy efficient devices support sustainability. So for the last one is political. Malaysia supports digital health through My Health and telemedicine. Policies encourage early detection and monitoring of diseases like hypertension.
Assalamualaikum and hi, today I want to show you this is our prototype and this is our component that we use to build the prototype. First is battery casing to supply the power, next is the component and the board. Then we take the board from the electronic blood pressure monitor and use the pressure sensor to get the value. So this is our motor to pump the blood pressure from our hand to get the value. So this is our real test for real life situation. If we need to use the prototype, after we get the value, it will transfer the value through the apps that we built and it will shows the blood pressure through our phone. So this is our testing video or our testimony from our own client. So as you can see that the prototype is functional and we get the value from the blood pressure monitor. So after we get the end value or the final result, we will transfer it through the apps and we will see through the phone.
This is our BP monitoring application. Now, let me introduce the way to use the application. Click on the button of Connect BT. This the Bluetooth device list. Select BP monitor to connect. The status will change from disconnected to connected. Click button Get Reading to get data from ESP32. The app will also categorizes the reading based on medical standards. Next is the block design for this part. For normal status. For elevated. For stage 1 high blood pressure. For stage 2 high blood pressure. Click the button View History to review previous record. The format of reading stored is date, time, followed by systolic, diastolic, and pulse. Click the back button to return main screen. If you wish to clear the records, you can click on the button of Clear History. Alert that it will delete all the history.